yesterday we started learning about soil with our friend Nicole, and we learned so much, and we have so much more to learn that she's back today, and I'm gonna let her take it away so we can keep learning.
All right, thanks, Robin. Okay, so first, I guess there are some of you who were not here yesterday. So yesterday we learned about soil. We learned what soil is and how it's different all across the world. So I just put together a quick little overview. Okay, so overview of yesterday. We learned that soil is the product of the physical, which is this here, chemical and biological weathering of sediments, rock, and organic material that we call the parent material. Do you guys see this green thing? I didn't mean to make that show up. I don't know how to make it go away, so we're just gonna deal with it there.
You didn't, you didn't do that. Hey guys, stop writing on the board. Please stop writing on the board.
All right, anyway, the soil, we see this cross section of the soil here is called the soil profile, and that is separated into these layers that we call horizons, and they're each different from each other based on how they were weathered physically, chemically, biologically. They each have their own special characteristics that are different from the ones directly above and below them. Even more overview, we learned that there are 12 main types or orders of soil that are different around the world. Yesterday, I only showed you a map of the United States, but here I wanted to show you how it's different across the whole world, and we can really see how different climates and regions affect what kind of soil is made. So does anybody remember what the formation of soil is dependent on, and what kind of soil is made, like what that word is called, that funny word that we learned yesterday? Somebody wants to like write it in the chat, maybe. Funny word.
Liv's got it.
Got it. Oh, so close. It's chlorpt with a T at the end. So that, but don't forget the T at the end. So, does anybody who was here yesterday remember what the CL, and that's cool that you put the period, you put the CL together, because the CL is actually one word. Does anybody remember what that word was? If not, you can type that in the chat so we don't have to keep muting and unmuting everybody. Yes, climate. And so climate refers to how hot or cold it is, how wet or dry it is, how often it's wet or dry. That plays a big part. How about the O? What does the O stand for? Liv, are you typing? Or are you thinking? All right, do you want me to just say it? All right, the O stands for organisms. And so that, yeah, the organisms, so the things that are living in the soil. What is in the soil that's changing the parent material, and what is it turning it into? That all changes depending on what kind of organisms are in the soil. Just to sort of go through the rest of it, the R stands for relief, which if you guys remember has to do with the topography, with whether it's on a hill or if it's flat. If it is on a hill, how steep is the hill? Is it in a valley where things tend to all collect down, or is it somewhere that things tend to get washed away? The P is the parent material. Remember, that's the rock and the sediments and the organic material that goes into becoming the soil. And finally, the T in this clorped stands for time. And so that has to do with how long these soil forming processes are happening. So the longer soil gets to form, the more developed it's going to be, the more horizons it's going to have. All those factors go into what kind of soil is made. And one thing that Robin pointed out yesterday that I want to remind you guys is that with these horizons, some soils don't have all of these horizons. Some soils only have an A and a C horizon. Those are the newer soils that didn't get the chance to build up these other horizons. We have something in the chat up here. Oh, just Jaden saying hi. Hi, Jaden. Okay. So let's see what's next. So there's one more thing that I didn't really get to talk about, but remember how I told you guys that we could get a little sample of the soil that's in our backyard and put it into a jar to see the composition of the soil? So this right here is a diagram that geologists are very familiar with. And one thing I will tell you is geologists love our triangular shaped diagrams. Maybe if you guys want to have me back to talk about rocks, I could show you some more triangular shaped diagrams that look like this. They're so much fun. So all soil is made up of some mixture of sand, clay, and silt. And so sand, you've seen sand before, you've gone to the beach or wherever, it's pretty coarse, right? Like you can see the individual grains. And then silt is where we get sort of those finer grains, they're really thin. And then clay is the absolutely super finest. And that's where you get like mud. And so how we calculate this. So first I'll talk about the soil texture test. So you fill the mason jar up. So I live in Philadelphia. I really don't have a backyard with native soil. I really just have potting soil. So I took some potting soil and I put it in a jar. I mix it with water and I'm shaking it up. And right away, since the sand particles are the biggest and the heaviest, they start to settle out first. And so you can't really see it because it's potting soil and it's very dark. But within like a minute, the sand will start to settle in the bottom. And then the silt particles, because they're a lot finer, they're lighter, and so they stay suspended in the water for a few hours. And so after a few hours, you'll start to see the silt particles filter out. And then clay, the super, super small clays, they like to stick to the water and they like to hang out in the water for a really long time. And so clay will take a day or two to filter out. But then after that, you will see these layers. I've just found this picture on the internet. But you'll see these layers of, this is the sand, the silt, and the clay. And so how we calculate the percentage of each sand, silt, and clay is we take the whole, I'll be right back. Let me get my stylus for my computer. Okay. So we would measure this whole height here, and we would calculate that. We would put that total height in the bottom. And then we would measure the height of just the sand and the height of just the silt and just the clay. And for each of that, if we wanted to calculate the percentage of the sand, we would put this thickness over the total, and that looks like it might be about a little over 50%. It looks like maybe half, maybe 50, 60%. So that's how you would get that. And then plotting this, somebody's putting dots. Thank you for taking those away. So plotting this, let's say we did have 60% sand. Say we had 30% silt. And then what would be left if we were doing 100% and we had 60 and then 30? What would be left? Jaden? Oh. Unmute yourself maybe, or type it in the chat. Yes, 10%. And so after that, we would have 10% of the clay. Okay, so this diagram can get a little tricky. Sometimes it even confuses me. So we have to take these percentages, we have to find them along these edges here, and we have to draw lines for each one. And then wherever these lines, you see these lines here, whatever line, wherever they intersect, that intersection will be what kind of soil you have. So with 60% sand, here's the percent sand on the bottom here. So we're gonna make a line at 60. Now, the question is, do we go with this line or this line? We're gonna go with this line because we have, we're gonna go with this line because we have the sand in this corner. And so the other line to this corner is here. So we're gonna connect this across here. And then, sorry, that's a rough line. And then we have our 30% silt. So we go to our percent silt here, 30. And then the other side of the silt is here. So we're gonna go this way. And then that leaves us with our percent clay. Our percent clay is on this side, and that's 10%. So we're gonna come across here, and that leaves us right here. So what kind of soil is right here? We call that a sandy loam. And lots of funny words for soil, but yes. So if you guys wanna do this fun little mason jar thing and come back and we can talk about maybe what kinds of soils we all have in our backyards. So.
Do you all think that you can do that? Thumbs up. I think it would be super cool to try to figure out what all of our soils look like. And then in future lessons, when we're learning about plants or mushrooms, we can have a better idea in our own brains with the soils that we have in our backyards about what we can plant or what we might find and that sort of thing. I think it's a really, really useful thing, really useful test, and super fun to figure that out.
Mm-hmm. Yeah, cool. All right. So moving on to the main thing I want to talk about today is soil pH and the acidity of soil. So just kind of on a scale of 0 to 10, with 0 being you have absolutely no knowledge at all on acids and bases, and 10 being you aced your test on acids and bases in your chemistry class, which I doubt any of you have actually taken a chemistry class. So if you guys want to show me on your hands your level of confidence in how much knowledge you have on acids and bases. That's just 5, maybe 4, 3, 6. Cool, so we got a range. Awesome. So, who has seen this before? That's called the pH scale. And so, on the left here, this 1 through 7, we call the acids, and then 7 through 14 we call bases, and then right in the middle is pure water, and we call that neutral. And does anybody know why? Why is water neutral? Liv, do you have an idea? Wait, I can't hear you.
hear me now?
Yes.
Okay. Because it's really simple. It's just water, and it just has like really simple elements like hydrogen and oxygen.
Yeah.
Doesn't anything like sodium.
Yeah. Yeah. So what is the chemical formula of water?
H2O.
H2O. Okay. Let me see. Yes. All right. So the reason that water is neutral, and what I'm about to tell you, this might go completely over your head, and if it does, that's perfectly okay. If you come out of this learning just even a little bit, I would be so happy, but don't feel bad if any of this you're like, what in the world is she talking about? So water is H2O. And another way that we write water is like HOH instead of H2O. It's just a different way of writing it. And so in a water molecule, these hydrogens, this little symbol here, that's a little delta, and that means just a little bit. So this is just a little bit positive, and then this oxygen on this side is just a little bit negative. And so when water is in a solution, oh, and these, so this here and this here are the things that make solutions, that make substances acidic and basic. And so water is just the perfect ideal combination of this and this to make it perfectly neutral. So, get my notes here. Okay.
And
So,
when she's saying positive and negative, she's talking about electricity.
Hmm?
They have electrical charges that keep them together.
Yes. Yes. So when water is just water, these are all for the most part together as one molecule. But then when water is mixed with something else to make a solution, depending on what it's mixed with, some of the water molecules will separate into this hydrogen, slightly positive, and we call this OH, we call this hydroxide. And that together is just slightly negative. And so the pH scale is actually, we get these numbers 1 through 14. Some crazy wild math goes into getting these numbers that basically comes down to how much of these little positive hydrogens or negative hydroxide ions are in the solution. So acids generally have more of the hydrogen ions, and and bases generally have more of the hydroxide ions, and that's really nothing that you need to know. Just facts. So how does soil become acidic? There's a couple different ways. Organic matter on the surface of the soil, when it breaks down, when bacteria or little critters or fungi or whatever work to break down organic matter on the surface of the soil, that creates acidic compounds. Like one is, I know, humic acid. If you remember yesterday, I told you that that O or organic horizon sometimes is referred to as humus. And so that forms humic acid when it breaks down. And so then that will seep down into the soil, putting acids into the soil. And then depending on the chemistry of the soil, sometimes there are nutrients like potassium, calcium, and nitrogen that will act as what we call buffers that will react with those acids and sort of neutralize it so that it doesn't become too acidic. And so that goes into the chemistry of these parent materials, determining how soil becomes acidic and how acidic it becomes. So when you have a soil with lots of limestone in it. The chemical formula for limestone is calcium carbonate. So the Ca is the calcium, the CO3 is the carbonate. And then when that reacts with either, you know, the acids that come down into the soil, or maybe acid rain too is another thing that makes soil acidic, that will react to sort of make it more towards neutral. And then there's some sands like the spota soils that I told you about, the sandy soils that are like in the Pine Barrens in New Jersey. Those have lots of sand. And for the most part, sand, silica sand, is just SiO2, another really simple molecule like Liv talked about. And because it's so coarse in sand, has anybody, like, you've taken a bucket of water at the beach and dumped it on the sand? You've seen the water just kind of goes right in. It just rushes right through. It basically just disappears. That's what happens in sandy soil. Water goes through and it just goes straight down. And what it likes to do is, if there were any of these nutrients in the soil, it likes to hang on to those and pull them down. And so then these heavier elements like iron and magnesium get left behind. And that's like, you remember the picture that I showed you of the sandy soil that had that red layer in it? That's the iron oxide. That's the oxidized iron that was left behind in the soil. And then the rest of it is so light because it's so sandy.
Do we have some questions? It looked like Jaden and Baron might have had their hands up.
Yes, please give me questions if you do.
Can you guys unmute yourself? Do you have questions? Or you can shake your head no if you didn't have a question. No questions? Okay. Do people,
Okay.
Is this sinking in with people at all? Do you have, is it like, I don't get this, or this is making sense because, and I'm thinking about the soil that I have and that I've seen.
Mm-hmm.
Does anybody want to try to put any of it into their own words with like the soil that they have in their backyards or something?
Jaden?
Well, our soil is very clayey.
Okay.
And it kind of, what's the word? Like certain places, like you said, it's sandy soil, but ours has a lot of clay in.
Uh-huh.
There's not really much. It's just like pebbles too, like rocks.
Mm-hmm.
Rocks too, depending on where you are, because we have a huge backyard.
And it's really clayey.
Yeah, I'll show you. Let me.
Cool.
Okay.
All of that.
Yeah. When it rains, does the ground stay really wet when it rains?
Yeah, a lot.
Yeah, you get like puddles a lot.
So many.
So many puddles. That's because your soil is really clayey. I told you that clay particles are really, really small, and they're also really sticky. So when you have a lot of clay particles and they get wet, they stick together. Like, have you guys played with clay before, like modeling clay or done like any sort of pottery? It's really sticky, right? And it likes to hold on to water. So when you have really clayey soil and rain comes down, it's really hard for it to soak into it and go through it, as opposed to the really sandy soil that's in Robin's backyard that, you know, rain falls and a lot of it just sinks right into the ground. So yeah, that's really cool. That's a really cool observation, Jaden. Thank you for sharing what's in your backyard.
You're welcome. Oh, and sorry for showing you my room.
It's okay.
Not mean to do that.
Does anybody else have any questions? Anything you're needing clarification on? All right. So why do you think the pH of soil matters? Why do we care about how acidic soil is? Liv?
Then we know what to grow there.
Yeah, we know what to grow there. And why would that tell us what we need to grow there?
because some plants like acidic soil and some plants like basic soil.
Mm-hmm. Yeah. Yeah, another word for basic that we use sometimes is alkaline. So just another word that we use. We sometimes, especially like referring to soil, I've heard soil referred to more as alkaline versus acidic. So just in case you hear that and you get confused, just know that it means the same thing as basic. So yeah, different plants like different soil pHs, and that is because the pH affects, which nutrients can be available to these plants. So some more complicated chemistry. Soil can contain a wide variety of nutrients in the soil, but whether or not the roots of a plant are able to suck it up, what we call uptake of these nutrients, is dependent on the form that it takes in the soil. And so depending on the chemistry of the soil, the pH of the soil, that can change these nutrients a little bit and their chemistry so that the roots are more able to hold on to them and suck them up into the plant. So this green box here is the general optimum soil pH range. But as you can see over here, remember how I told you that in really sandy soils that are acidic, what's left behind is the really heavier nutrients like iron and stuff. So that's why there are certain plants that like acidic soil, because the nutrients that they like are available in that pH. But most of the time, within 6.2 to 7.3 is what plants generally like, because that is the optimum conditions for these nutrients to be available to the plants to suck them up and grow. Would Robin like to add anything to that?
No, I mean, I'm actually learning a lot here. I think that this is a really, really great diagram.
You know, I saw this, I was like, oh, Robin's gonna love this.
I think that what Liv said about, you know, the certain plants, you know, liking certain pHs, and, you know, I know what I read, you know, when I see the kind of, when I'm researching a plant and it says it likes alkaline soil, or it likes acid soil, or it likes sandy or silty, like I pay attention to that. But I didn't know a whole lot about like the real nitty gritty of why. So this is really great. Thank you.
Yeah, oh, I'm glad everybody's learning something. Liv, you love chemistry. I love chemistry. Before I was a geology major in college, I was a chemistry major. I love chemistry.
I love chemistry too. It's very hard.
Yes, I'm so happy you're learning chemistry right now. That makes me very happy. And I hope everybody else loves chemistry, and it's really not as scary as I think people make it out to be. Does Jaden have a question?
Can you hear me?
Mhm.
Okay, great. I actually used to do chemistry classes with a teacher, and then I also went camping last weekend, and we found wintergreen, and also we made dandelion fritters and smoothies today.
Wow.
Cool. Yeah.
Oh, that sounds really cool.
Jaden, do you remember what kind of soil wintergreen likes?
Acidic.
Yeah. Did you see any blueberries where you were also, maybe?
We actually are growing blueberries, and also pine trees like acidity too.
Yeah, cool. That's great. I'm glad you remember all of that. And dandelions, so dandelions are one of those plants. They're a plant that doesn't really care.
Yeah, it's like a
Dandelions are like,
neutral plant.
yeah, they're like, we'll grow wherever. It doesn't matter. Our seeds will land and they will take root and it doesn't matter. And that's cool too. It's really nice to know what plants are like. Put me in any soil conditions. I don't care. I'll grow.
Yeah, aren't violets like the same way?
Kind of, yeah. I think they prefer certain conditions.
Yeah,
But
I think it's like this. I think they like a little bit of acidity. 'Cause we have a pine tree in the front, and that's where our violets are.
I think so too. I agree. Based on my observations, I think that violets like acid too.
Yeah, we went camping and we saw a lot of birds. There was also sand dunes. We saw deer, turkeys. It was really cool. Except I had to wake up at like 5 in the morning to leave. It was annoying, but I still think worth it. Yeah, and like the hill was literally just downward with wintergreen.
Wow.
So cool.
That's great.
Yeah, is that a
so when
kind of pine tree?
when we came back here though, there was none. No wintergreen at the park, no wintergreen at our house. So I guess we don't have that acidic soil.
I think, remember, it also really like wintergreen also really likes shade, and I think it might be a pretty slow growing plant maybe, so it needs a good amount of time to get established in a space, and a lot of times other plants take over before wintergreen can grow, so it needs like really, I think, specific conditions.
Maybe because we have a lot of trout lilies. Tons of trout lilies. You could like feed like billions of people with how many we have. Okay, I'm exaggerating a little bit, but you know what I mean.
Yeah, trout lily's another one that likes wet conditions. Probably likes the clay that you have.
Yeah, it's our park.
Yeah. Does anybody else have like plants that they've seen it recently that maybe could help us figure out what the soil was like where you were? Anybody been outside and noticed anything specific? Liv, and then we'll get back for the last few minutes to Nicole. Liv, you can unmute yourself.
Wait, can you hear me? Okay, cool. I've seen a lot of dandelions, but I think that might be because it's dandelion season. So I don't know. What kind of soil do they like?
I think that, so dandelion kind of will grow anywhere, but one of the things that dandelion does, one of the things that makes it great is that it can grow in soils that are that don't really have any nutrients at all, or don't have very many nutrients compared to really fertile soil. They're called, sometimes people call them pioneer species. Like they're one of like the first species that will take over when an area is called, when it's called disturbed. So disturbed space is anywhere that's been like dug into, or like where the plants have been cleared away and made bare soil, or like where a new house has been built and there's nothing around, or a house has been demolished. And there's just like bare earth, and sometimes it's like really gross looking. Dandelion loves that. Kind of loves everything.
All right. So I guess we have about 3.5 minutes. I just wanted to, real quick, there was one type of soil, since we have time, that I didn't get to talk about yesterday that is my favorite kind of soil. I didn't know it existed until I took my soil class. And that is the vertisol that we call swelling soils. And those are super clay rich. And those have the kinds of clays that swell. And so because of the chemical structure of clays. Usually they're in sheets, and the space between the sheets of these clays will fill up with water. And so this whole soil profile, when it rains, will expand, and it will literally grow up. And because of the clay and just because of physics, basically, there are these preferential lines that when the soil expands, it has to move against itself. And so it'll form these planes where the clay will slide against itself so that it can move up. And so you'll see, if you can see here, does everybody see this diagonal sort of swooping line here? And then we see it over here too. And these, if you can see right here, this surface here is the surface where the clay will slide against itself when it's shrinking and swelling. And it has these, it's kind of hard to see, but it's super smooth, and it will have these, it's called slicken lines. That, have you ever like taken like clay or mud or something and like smeared it, and you can see like the lines of the direction that you smeared it? So that will show up in the surface of the clay, and we call those slicken lines or slicken sides. So yeah, that's just one kind of soil that I think is really, really cool, and it has these just distinct like wedge shapes, and this movement of the clay goes all the way down to like microscopic size. So if you were to take take a microscope and look really, really close, even just the little pieces of soil that are in here, you'll see those as little diamond-shaped wedges, because all the way down to like the molecular structures, they're still sliding against each other at this angle. Robin?
Is this how mudslides happen?
It definitely, mudslides are possible in these kinds of soil for sure. There's probably a lot of different ways that mudslides happen, and I can definitely look into that and come back and let you know. It's been a while since I took like a geomorphology class. But yeah, I think these kinds of soils are super cool, and we only have about 40 seconds left. I set a timer on my phone so I wouldn't get cut off this time.
Almost.
Does anybody have any questions in the last 30 seconds?
Liv's mind is blown. This is great. Nicole, we probably will want to have you back in the future. So I'll talk to you about other things we can do. This is really wonderful. And tomorrow,
I would love to come back.
I think tomorrow I'm gonna do some sort
Bye.
of, like, desert plant or something.
Bye.
I can tune in on that. Thank you. Bye.
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 3,